Okay, from the wrapping function, we knew that pi over 6 mapped us to a point to root 3 over 2, 1/2. But now, since we have angles, we know that that pi over 6 measurement over here is actually our angle measurement also. So if we draw an angle in here, we know that this angle measurement is pi over 6. Now, because we know how to convert between radians and degrees, we also know that that is 30 degrees. Now, since we can draw reference triangles inside our circle with a right angle, we can talk about the sine of 30 degrees and the cosine of 30 degrees being root 3 over 2 and 1/2. By the way, this is a 60 degree angle here also. Similarly, if we talk about pi over 4, which maps to right here, and we knew that what the points were root 2 over 2, root 2 over 2, we have a 45 degree angle now because pi over 4 is equal to 45 degrees. We now have a reference triangle with an angle of 45 degrees. And so we can just say that the sine of 45 is root 2 over 2 and the cosine of 45 degrees is root 2 over 2. And then finally also the same thing happens with pi over 3, which is 1/2 root 3 over 2. We now have an angle that is pi over 3, which equates to 60 degrees. For this whole angle right here. If you notice something, that this is also 30 degrees, so these two triangles are exactly the same, except for we have the short leg here, and the short leg was right there, and the long legs here, which now it's vertical. This brings us to something very, very, very important, because now we're using reference triangles all over the coordinate plane. We can use those triangles here for different values, like 3 pi over 4 and 5 pi over 4, and so on and so forth. We need to know our famous triangles. Okay, I had to reframe this. So we have our famous right triangles. The first one is a 45, 45, 90 triangle for obvious reasons. We have two 45 degree angles and a 90 degree angle. There's two ways to remember this triangle. You can remember it as side length 1 and 1 because these two side lengths have to be the same, and root 2. The other triangle is 30, 60, 90. Small angle 30 degrees, large angle 60 degrees, obviously our 90 degree angle. Short leg would be 1, hypotenuse is 2, and the long leg would be root 3. This is probably the way you memorize these triangles in geometry. But we've already looked at these triangles in another way from the wrapping function version, and sometimes it's easier to remember them this way, is that this side would be root 2 over 2, this side would be root 2 over 2, and of course our hypotenuse is 1. Over here on the 360-90 triangle, hypotenuse 1, short leg is 1/2, and long leg is root 3 over 2. Now, why do you want to memorize these triangles? Because these triangles are what we're going to use as our reference triangles on the coordinate plane for a lot of trig functions. For instance, let's say you had to come up with 6 trig functions for 315 degrees. Well, 315 degrees is way over here in quadrant 4. That produces a reference triangle that has a central angle of 45 degrees. Now, because you memorize your famous triangles, you know that this side length is 1, this side length is 1, and this hypotenuse is root 2. Therefore, x equals 1, y equals, in this particular case, because it's going negative, you have to say -1, and then r equals root 2. It's probably a good idea to label your triangles with that negative one there also. Now you can go ahead and figure out your sine of theta, your cosine of theta, and so on and so forth using the x, y, and r's.